In this example, we are going to solve this trig equation, and we're locked into the interval. Our answers are going to come from 0 to 360, not including the 360 because it would just be a repeat of the 0. So first thing is, since you're solving, we have a little bit more things that we can do than verifying. So since we're solving, we can actually divide by 6 on every single piece. That way we can actually just get rid of the 6. So now you're looking at tangent of theta minus cotangent of theta equals 0. Now there's a couple different ways you could go here. Since there's no squares on it, there's no kind of substitutions where I can take tangent and replace it with cosines or secants and whatever. So instead, what I can do is I can turn this into a sine over a cosine and a cosine over a sine and get some common denominators and add things together. Or another route is I can bring this over to the other side. So if I bring that cotangent over to the other side, I'd isolate tangent on one side, and it would turn cotangent positive on the other side. And then I can turn it into sine over cosine. And this is going to get me the same result, just a different route of getting common denominators. And then cotangent is cosine over sine. And then, since I have a fraction, I can cross multiply. So this is kind of a different approach, since I knew I was going to be able to just get a fraction equals a fraction, and it's a proportion, cross multiply. So I'm looking at sine squared theta equals cosine squared theta. And then I can pull them together. So we're looking at sine squared theta minus cosine squared theta equals 0. All right, so it's good, but not quite there yet. So what I can do next is I'm going to sub out sine squared. And if you remember, sine squared plus cosine squared equals 1. So if I isolate the sine squared, I would have a 1 minus cosine squared to replace it with. All right, and that's exactly what I'm going to do. So I'm going to take the sine squared and replace it with a 1 minus cosine squared theta minus cosine squared theta equals 0. And then from there, I have 1 minus 2 cosine squared theta equals 0. All right, so now I can solve this. So if I solve this, I'm going to subtract 1 and divide by 2. So that would leave me with a cosine squared theta. I'd subtract 1, divide by -2, so that would leave me with a positive 1/2. We would square root both sides. And so cosine theta this is the square root of 1, which is 1 over square root of 2, which if you rationalize it, but I actually don't want to. So I'm going to leave it as a plus or minus 1 over square root of 2. And that comes from a 45, 90. So that's a special triangle that I'm going to be pulling that information from. So 45, cosine of 45 is 1 over root 2. So that's where I get my 1 over root 2. And I would be looking at all the quadrants. So my reference angle is 45, but I would be looking at every single 45 in every single quadrant. Okay, so my answers would be 45, 135, 225, and 315. Okay, so theta is going to be 45, 135, 225, and 315. All right, the last thing I'm going to do is double check that this is right by using a calculator. The issue that I may have on this is the fact that my original started with tangents and cotangents, and they have domain issues. Cosines and sines don't, but I changed my equation out of tangents and cotangents. So I do want to check to make sure that these answers work. And I can check that very quickly and easily with my calculator. So, so to do that, I'm going to graph this original equation with the 6's included. So 6 tangent minus 6 cotangent. So 6 tangent of that. Before I do that, let's make sure I'm in degrees. So 6 tangent x minus 6 times 1 over tangent x. And that is what I'm graphing. My window, I want to go from 0 to 360. Let's try that again. 0 to 360. And then I want to go by 45s. So if I go by 45s, I can kind of count to see my 45s and kind of match everything. And I'm looking for x-intercepts, so I don't really care about the rest of the graph. So I'm going to focus around those points. Press graph, and that's 45. That's 90, and that's 135. And then that's 180, and then that's 225. Perfect. And then there's my 315. Great. So those are my solutions. I don't miss anything. There's no domain issues. And those are my 4 answers.